Welcome back, everyone, to the Deep Dive. Today, we're going to do a deep dive into OmniParser.
OmniParser.
Which is a new tool for making AI agents even smarter.
Yes.
Especially when it comes to understanding what they see on a screen.
Right.
So you might be interested in this deep dive if you're curious about the cutting edge of AI, or maybe you're thinking about how this tech could change the way we interact with computers in the future.
Absolutely.
And to do this deep dive, we have a research paper from Microsoft Research and a couple of blog posts about OmniParser.
Sounds good.
So let's dive in.
Yeah.
So OmniParser is tackling this challenge of UI understanding for AI agents.
That's exactly right.
And we're going to explore its unique approach and how it compares to other methods and kind of what this means for the future of AI interaction.
Yeah, it's exciting stuff. And the paper really digs into how this tool can help AI understand what they see on the screen like we do.
Yeah. Okay, so the problem that OmniParser is trying to solve is that current large vision language models, like GPT-4V, are really powerful, but they struggle to interact with user interfaces effectively.
That's right.
So even though they're really smart, they have trouble with, like,
They do.
navigating websites or apps.
Yeah, you can almost think of it like
I'm surprised.
you and me both. It's like, imagine trying to read a web page where all the buttons are just like random shapes with no labels or anything. You might be able to see them, but you wouldn't know what they do or how to interact with them.
Yeah.
And that's kind of the challenge that these models face.
So they need a way to understand what those things do, not just see that they're there.
Exactly. They need to understand the function of those elements on the screen, not just that they're there visually.
Okay, so that is where OmniParser comes in.
Yes.
So it's like a translator that helps the AI understand the meaning behind those visuals.
Exactly.
Okay, so how does it actually do that?
So OmniParser uses a two-step process. First, it uses what's called a detection model. And this helps to identify all the interactive elements that are on a screen.
Right.
Things like buttons, icons, links, anything that you can click on.
So it just spots all the important things.
Yeah, picks out all the important stuff.
Okay, and what's the second step?
The second step is where the caption model comes in.
Okay.
And once it knows where those buttons are, it needs to figure out what they do.
Right.
What's their function.
Okay.
And so the caption model is trained to basically associate icons with their function. So it's kind of like giving the AI a visual dictionary.
So it learns that the little play button means play.
Exactly.
Or the gear means settings.
You got it.
Okay.
And so by combining these two models, OmniParser enables the AI to not only just see those elements, but to also understand their purpose, which is really crucial for interacting with any kind of interface.
That's really cool.
Yeah, it's a pretty neat solution.
Yeah. So how well does it actually work in practice?
So to test this, the researchers put OmniParser to the test, and they compared it against some other methods using 3 different benchmarks.
Okay, let's hear about the benchmarks.
All right, so the first benchmark that they used is called ScreenSpot.
Okay.
And it essentially tests the AI's ability to find and click on the right element on a screen.
But just how well it can do it.
How accurate it is.
Yeah.
Exactly.
Okay.
And in this benchmark, OmniParser just blew the competition out of the water.
Wow.
It consistently outperformed the other models, including models that were specifically designed to do this.
Really?
Which was really interesting and kind of shows the power of this approach.
Okay, so that's one for OmniParser.
That's one for OmniParser.
What's the second one?
The second benchmark is called Mind2 Web.
Okay.
And this one is all about web navigation.
Okay.
So the AI is given instructions like book a flight from New York to LA, or find a restaurant that serves Italian food, and it has to use just the information that it has to figure out how to navigate through that website and complete that task.
So it's like a real-world test.
It is a real-world test.
Wow.
And OmniParser was able to achieve all of this using just screenshots.
Wow.
No peeking at the website's code or anything like that.
So it's basically navigating the websites by looking at them just like we do.
Yeah, it's pretty remarkable.
That's amazing.
It really is. And get this.
Yeah.
On this benchmark, it actually did even better than GPT-4 with HTML assistance.
Right.
So just pretty wild.
GPT-4 had like extra help.
Extra information.
And OmniParser still did better.
Yeah.
That's wild.
So that was really impressive.
Wow. Okay, so 2 for 2 so far for OmniParser.
2 for 2.
What about the third benchmark?
All right, so the third benchmark was AITW.
Okay.
Short for Android in the Wild.
Okay.
And this one focuses on navigating mobile apps, which can be a little bit trickier.
Yeah, because it's smaller.
Smaller screens.
And different layouts sometimes.
Yeah, you've got all kinds of different things going on.
Yeah.
And so
So how did it do?
once again, OmniParser came out on top.
Okay.
It consistently outperformed GPT-4V, showing off its ability to adapt to these different platforms,
Right.
which is really one of its strengths.
It's like a versatile tool.
It is.
That's really cool.
So we're seeing this pattern that OmniParser does really well
Yeah.
across these different tasks and platforms.
Right.
And so this kind of suggests that its vision-based approach could really be a game changer for creating these AI agents that can just seamlessly interact with all kinds of different digital environments.
Yeah, that's really interesting.
Yeah, it's super exciting.
So it seems like it's a really big deal in the world of AI.
Definitely.
But I'm guessing it's not perfect.
Of course not. Nothing is perfect.
So are there any limitations or like challenges that OmniParser still faces?
So there are a few situations where it can trip up a little bit.
Okay.
One of the things that it can struggle with is repeated icons or text. Like, for example, if a screen has multiple identical buttons, OmniParser might not always pick the right one.
Right.
Because it doesn't have that context to understand which one is the right one in that moment.
So it sees that there are 3 buttons that all say the same thing.
Exactly.
But it doesn't know which one is the one that it needs to click on.
Right.
Okay.
And they saw this in one of the tests where OmniParser had trouble distinguishing between several enable buttons for different alarm times on a phone's alarm app.
Yeah.
So it saw those buttons.
Right.
But it didn't really understand the context of which button was associated with which alarm.
So what else can cause it problems?
Another limitation is that sometimes the bounding boxes that it draws around elements aren't precise enough.
Bounding boxes.
What are those?
So you could almost think of them like the boxes you would draw around objects in a picture.
Okay.
And OmniParser uses these boxes to tell the AI where to click.
Okay.
But if the boxes are off a little bit, it leads to misclicks.
So it's trying to click on something?
But because the box is a little bit bigger or smaller or whatever, it's
a little off.
It's clicking on like the wrong thing.
Exactly, like when you try to tap a link on your phone, but you end up clicking something else because your finger was just a little bit off.
Oh, yeah, I hate that.
It's so frustrating.
Yeah.
And so we see this happen where OmniParser tried to click on a link that said more, but it actually missed the clickable area because the box was a little bit too wide.
Oh. So it understood what more was.
It got the concept.
But it just couldn't physically
Just couldn't execute it properly.
click the button.
Exactly.
Okay, so repeated icons, imprecise bounding boxes, anything else.
The last one that we'll touch on here is that it can misinterpret the function of an icon, particularly if context is key.
Right, like it can't tell the difference between a 3-dot button that means more options versus a 3-dot button that means it's loading.
Exactly. And that's because it doesn't have that surrounding information to tell it what that icon means in that particular context.
Right. So it's like looking at a single word without the rest of the sentence.
Exactly.
Yeah.
And so this kind of highlights that while OmniParser is a huge step forward, there's still work to be done in helping AI understand those nuances of visual information.
Right. So despite all of these limitations, it still seems like a really big step forward.
Absolutely.
It's pretty amazing what it can already do.
It is.
So what are some key takeaways that we should be thinking about?
Well, I think the biggest takeaway is that OmniParser represents a shift away from relying on additional information, like HTML or other things, and instead relying solely on this visual understanding like we do as humans when we interact with the screen.
It's like truly seeing it.
Exactly.
And understanding it.
Yeah.
Okay, what else?
Another key takeaway is that its success really hinges on combining that accurate element detection with understanding its function.
Right.
So it's not enough for the AI to just see those buttons. It needs to actually comprehend what they do in order to interact meaningfully.
Like, I need to know that the button that says play means that it's going to play the video.
Exactly.
Okay, cool. And the last takeaway?
The last one, and this is a big one, is that OmniParser can actually work with many different large vision language models.
Okay.
Which makes it a really promising potential plugin for all kinds of AI systems in the future.
Yeah, so it's not limited to just one type of AI.
No.
That's really cool.
Which is really exciting.
Yeah, so we've covered a lot of ground today.
We have.
From how OmniParser works to its performance and some of its limitations.
Yeah.
But we're just getting started.
That's right. In the next part of our deep dive, we'll delve deeper into the technical details of how this amazing tech actually works.
Okay.
We'll look closer at the data sets that they use to train OmniParser and explore the fascinating world of set of marks prompting.
Okay, so stay tuned, folks. We've got a lot more to uncover about OmniParser.
We do. Welcome back to our deep dive into OmniParser.
So last time we talked about OmniParser's performance on those benchmarks.
Yeah, and how effective that approach seems to be.
Yeah, and it did really well.
It did.
So now I'm kind of curious about how they actually trained OmniParser.
Right.
Like, how did it become so good at understanding these screens?
So it all comes down to the data that they use.
Okay, so you mentioned there were two different data sets, one for the detection model and one for the caption model.
Exactly.
So, like, how big are those data sets?
So the detection model was trained on a massive data set of 67,000 screenshots.
Wow.
And the caption model was trained on 7,000 icon description pairs.
Okay, so where on earth did they get all of this data?
So for the detection model, they took a really clever shortcut.
Okay.
They use a huge collection of popular web pages.
Okay.
And they basically extracted information about where the buttons and links were located directly from the website's code.
Oh, so they didn't have to, like, manually label
every button and link in 67,000 screenshots.
No way.
That's wild.
They leveraged the existing structure of the web pages to create the training data for the detection model.
That's so smart.
Yeah, it was pretty ingenious.
But what about the icon description data set? Did they do something similar for that one?
So for the caption model data set, they enlisted the help of another AI GPT-4.
Oh, wow. They used one AI.
They did.
To create training data.
It's like AI inception.
For a second AI, that's kind of mind-blowing.
It is pretty wild.
So what did they actually have GPT-4 do?
So they showed GPT-4 a bunch of cropped icons.
Okay.
And they asked it to first determine if the object was actually an icon.
Okay.
And then if it was an icon, they asked it to provide a short description of what it thought the icon's function was.
Oh, so they were basically using GPT-4's language abilities to label these icons.
Exactly.
Oh, that's so cool. Much faster than having humans manually label thousands of icons.
Yeah, for sure. Okay, so they've got these massive data sets. So now what do?
So that's where the machine learning magic comes in.
Okay.
They use these data sets to fine-tune existing models.
Okay, so they're not building these models from scratch.
Not necessarily, no. They take those existing models and then they refine them.
Okay.
Using this really specialized data set.
I see. So it's more efficient.
Exactly.
To use what's already out there.
Saves a lot of time and resources when you're dealing with these complex tasks.
Okay, so they've got the models trained up. Now, how does the AI actually, like, use this knowledge to interact with the screen?
So you mentioned something called set of marks prompting before?
Yes.
So this is also called sema-prompting for short.
Okay.
And it's a really clever technique.
Okay.
So instead of asking the AI to figure out the exact coordinates of an element on the screen, which can be really difficult and unreliable.
Yeah.
They give it a set of labeled boxes overlaid on top of the screenshot.
So instead of, like, trying to find one tiny spot,
exactly,
it has, like,
little area,
multiple options, and it can pick,
like a multiple choice quiz instead of a fill in the blank.
Perfect.
It's a great analogy. And so each of these boxes has a unique ID.
Okay.
And the AI simply has to choose the box that corresponds to the action that it wants to take.
So it's like, click on the button that has ID 5 instead of, like, click on the pixel at 235, 478.
Exactly.
Okay.
And so this makes it much easier for the AI to accurately target the correct element.
And probably a lot less frustrating for the AI, too.
But it's frustrating for everyone involved.
Yeah, okay, so it's analyzing the screen, identifying and labeling the elements, and then using this SOM prompting to make sure that it's clicking on the right things.
Exactly. And all of this using just visual information, no peeking at the code.
Yeah, it's actually seeing.
It's really seeing and understanding the screen.
Okay, like we do.
But we talked about limitations before.
We did.
So what are some of the things that it struggles with?
So one issue that comes up is dealing with these repeated icons or text.
Okay.
So if there are multiple elements that look identical on the screen, OmniParser might have trouble picking the right one.
Right.
Because it doesn't have that extra information to tell it this one is different from this one.
Right. Like if I asked you to go get my copy of a certain book,
right,
but I have like 5 copies.
Exactly. You wouldn't know which one to grab.
Unless I gave you more information.
Right.
And so this happened in one example where OmniParser had trouble distinguishing between several enable buttons for different alarm times.
Right.
So again, it was the context.
It was missing that context.
That it was missing.
Exactly.
Okay.
Another limitation is that the bounding boxes that are generated can sometimes be a little imprecise.
Okay.
So this means it might accidentally click on something slightly outside of that intended target area.
Okay.
And so this can lead to errors, especially when you're dealing with really small buttons or links.
So it's really important to accurately detect those small elements.
It is a very high level of precision is required.
And so this sort of shows that the underlying object detection model is still under development. It's getting better, but it's not perfect yet.
Right. So we've talked about repeated icons, imprecise bounding boxes. Yeah. What else?
And the last one that we'll touch on is interpreting the functionality of those icons, especially when context is key.
Yeah, we talked about that before. Like if you just see a 3-dot icon,
right,
you don't know if it means more options or if it means it's loading.
Exactly.
Yeah.
It all depends on where it appears on the screen.
Right.
What else is around it? What are those other contextual clues?
Yeah.
So OmniParser can identify and label the individual elements, but it still needs to get better at understanding the overall context of the screen.
It's like understanding a paragraph and not just the individual words.
Yeah, exactly.
Okay. So even with these limitations, it's still a really amazing achievement.
It really is.
Like it's really showing that we're getting closer to AI that can actually see and understand the world like we do.
I agree. It's super exciting research.
Yeah.
But we're not quite done with OmniParser yet.
Okay.
In the final part of our deep dive, we're going to look at the bigger picture.
Okay.
What does this actually mean for the future?
Yeah.
How could this change the way we interact with computers?
Okay, stay tuned, listeners. So welcome back to the final part of our deep dive into OmniParser.
It's been quite a journey.
It has. We've gone from, how it works and how well it works to some of its limitations. But now I kind of want to talk about, the bigger picture.
Yeah, the broader implications.
Yeah, what does this actually mean for the future?
Yeah.
We see all those sci-fi movies where AI takes over.
Yeah.
Is this a step towards that?
I think it's a fair question.
Yeah.
But I think it's really important to remember that technology in and of itself is neutral.
Okay.
It can be used for all sorts of things. Think about a hammer.
Right.
You can use it to build a house.
Yeah.
Or you can use it to cause destruction.
Okay, so it really depends on us.
It all comes down to how we choose to use it.
Okay.
And with a powerful tool like OmniParser, those choices become even more important.
Yeah, that makes sense. So let's talk about some potential applications.
Yeah.
How could this be used to make our lives better?
So one area where I think it has huge potential is accessibility.
Okay.
So for people with visual impairments, navigating a computer can be really challenging.
Yeah.
But imagine an AI assistant that can actually see the screen and guide them through those tasks.
Yeah, like reading text out loud.
Exactly. Read out text, describe images.
Yeah, that would be amazing.
It would make the digital world so much more accessible.
Yeah, for sure. Okay, so accessibility, what else?
Another area I think is really exciting is education.
Okay.
Imagine these really interactive learning environments where you have these AI tutors that can visually guide students through complex concepts.
Like walk you through a problem.
Exactly.
Yeah.
It would be way more engaging than just reading a textbook or taking an online course.
Definitely. And we could get rid of all the boring stuff.
Yes.
Like filling out forms, scheduling appointments, managing emails.
All the stuff that nobody wants to do.
Yeah, exactly.
You can have AI assistants
to do it for us.
Equipped with OmniParser.
Yes, please.
Free up our time for more important things.
Exactly. Okay, so accessibility, education, getting rid of boring tasks.
That's right.
Are there any downsides?
Of course. There's always two sides to every coin.
Yeah.
One concern that comes up is what happens to jobs.
Okay.
If AI assistants can do all these tasks that people are currently doing, what happens to those jobs?
Yeah.
So it's something that we need to think about.
As AI becomes more and more powerful.
As AI evolves, yeah, and how to make sure that people can still find meaningful work.
In a world with AI.
Exactly.
Okay, so jobs. What else?
Another thing to think about is privacy.
Okay.
If these AI assistants can see everything on our screens, including sensitive information, how do we make sure that's protected?
That's a good point.
So that's a really important consideration.
So we need rules in place.
We need safeguards.
To make sure that our data is protected.
Exactly.
Okay, so OmniParser presents us with these amazing opportunities.
Right.
But also some challenges that we need to figure out.
Definitely.
It could really change the way we interact with computers.
Yeah, I think it could.
But we also need to think about jobs and privacy.
It's an ongoing conversation.
Yeah, it's not something that's going to be solved overnight.
Yeah.
But it's something that we need to be talking about.
Absolutely.
Well, it looks like we've reached the end of our deep dive into the world of OmniParser.
Time flies when you're having fun.
It really does.
We've gone from the technical details all the way to the potential impact.
Yeah.
I hope our listeners have a better understanding
of what OmniParser is and why it's important.
And why it matters.
Yeah.
It's definitely a technology to keep an eye on.
It is.
It could really reshape our relationship with technology in some pretty profound ways.
So until next time, keep exploring and keep asking questions.
Absolutely.